Hello everyone. Today we'll be going through IGCSE chemistry and the main topic is chemical bonding. And this video is about non-metallic substances and covalent bonding. This will be according to the syllabuses of Cambridge Edexcel, AQA and Oxford. So as I mentioned, chemical bonding is the main topic and you will have to go through these three videos which are available in the playlist. Non-metallic substances or what? Non-metallic elements are found on the right side of the periodic chart. Right upper corner, from right upper corner is metallic character is decreasing. On the left side, metallic character is increasing. So non-metals are all on the right upper corner side. So these are all non-metals. So they usually gain or share electrons to achieve a full outer shell structure. So, every element in the periodic chart is looking for stable noble gas structure. So, these elements are also looking for full outer shell, which is a noble gas structure. Non-elements form covalent bonds. Non-metals are forming covalent bonds with each other by sharing of electrons. And examples are we can take diatomic molecules of like a nitrogen and oxygen, and water is also an example of covalent bonding. Carbon dioxide is also example of covalent bonding. So in nutshell, non-metallic elements do not have and give away electrons. They are not handing over, they are not donating electrons or accepting electrons. So instead, they share electrons. So sharing of electron is done by the covalent bonds. So to become stable, they become stable, forming covalent compounds like water and carbon dioxide. Next thing is we can discuss covalent bonding in detail. So each shared pair makes one covalent bond. So if they are sharing one pair of electron, it will be single bonding. They can share even two pair of electrons and even three pair of electron. Covalent bonding happens when two non-metallic atoms share electrons. Shared electrons attract both nuclei and keeping atoms together. Similarly, bonds may be single bond, double or covalent, triple covalent bond, depending upon the on the shared pairs. So molecules are neutral since no ions form. So we can take example of water. Two hydrogen atoms are sharing electrons with the oxygen, and the electron distribution is given over here. So oxygen has 6 electrons. It's sharing two electrons which with each hydrogen atom is containing 1 electron. So each hydrogen atom is covalently bonded with the oxygen. So in covalent bonding, atoms achieve stability by sharing electrons. This sharing creates strong bonds between non-metal atoms without forming ions. So in covalent bond, they are not forming ions. Even then, they are sharing their ions and they are sharing their electrons and forming the bond. So now we can go to the types of covalent bonds. There are single covalent bonds, double covalent bonds, and triple covalent bonds, depending upon the number of electrons they are sharing. If there is single bond, it will be formed by one pair of electrons shared. For example, H2 and Cl2 diatomic molecules are examples for this. And double covalent bond, two pairs of electrons, in total 4 electrons. So two pairs of electrons shared. For example, we can take O2. And triple bond is three pairs shared. For example, nitrogen example is shown over here also. So that more pairs shared, the stronger and shorter the bond. So they will be pulling nuclei with a higher force if it will be double bond or triple bond. So in that case, size will be smaller, but the bond will be strong. Multiple bonding increases bond energy. Bond energy means the energy required to break a bond will be higher, and affects the properties also. So covalent bonds comes in single, double, and triple covalent bonds, and the more electrons shared, the stronger the bond and holds the atoms together. So in this structure also we have shown this single bond between carbon and hydrogen, double bond between carbon carbon, and this is triple bond between carbon and carbon. So these are three types. Then properties of covalent substances usually have low melting point and boiling point, and because as compared to ionic bonds, they are less stronger than ionic bonds, so they require lesser energy. So lower melting points and boiling points do not conduct electricity because they don't have free electrons available for conduction of electricity. So it will be there will be non-conductors. So many exist as gases or liquids at room temperature because their melting points are low. So forces between molecules, intermolecular forces are weak. So lesser energy will be required to overcome intermolecular forces. Molecules are often small, like water or carbon dioxide, making them volatile. So they are converting from liquid to gas easily. Covalent substances have weak intermolecular forces, so they melt and boil easily. That's why many are gases or liquids at room temperature. So, in nutshell, if we see the properties, electrons are shared and no ions, only non-metals present. So, like NH4 plus will be ionic. So, low metallic melting points, no boiling points, and normally gases and liquids or solids at room temperature do not conduct electricity and normally do not dissolve in water. Then next we can go through giant covalent structures. These are the examples are diamond and graphite. Some non-metals form giant covalent lattice instead of small molecules. Atoms join in a strong continuous network. They have very high melting points and are hard solids. Diamond does not conduct electricity, but graphite does due to delocalized electrons. So, if we see the structure of diamond, this one carbon is bonded with four other um, carbons. So it is basically all sides are occupied, whereas graphite is having one side free and it's forming layers like one layer and second layer. So layer wise it's conductor, so it can conduct electricity like this one, and because of that free electron available in case of graphite. So not all covalent structures are small molecules. Diamond and graphite are giant covalent networks with very different physical properties. So these are like allotropic forms of carbon and they are having different properties. We will discuss this later. You will have to go through these chemical bonding topic. To cover this complete topic, you will have to go through these three videos which are available in the playlist. And thank you very much for watching. Take care. Bye.